This training is an overview of the Model 2596 self-cleaning strainer. The goal is to provide background information that will assist with technical quoting and sales. The Model 2596 self-cleaning strainer is designed primarily for water applications, not oils, chocolates, or anything else of that nature. There could be lubricants or other additives in the water, but it is primarily for water. The Model 2596 is differentiated from other products, such as simplex and duplex basket strainers, because it offers continuous flow. For example, simplex basket strainers require a shutdown for basket cleaning, and duplex basket strainers require the flow to be transferred to a separate chamber while the baskets are removed for cleaning. The 2596 strainer eliminates all of that, so the customer's operations don't have to stop. The 2596 strainer is appropriate for a large number of applications because of the wide range of available sizes that cover many different flow rates. We have standard sizes starting at 2 inches, with capabilities up to 60 inches or more. The 2 through 8 inch strainers are made of cast iron. The 10 through 16 inch strainers are constructed of ductile iron. And the larger strainers can be fabricated in a number of different materials, such as carbon steel. We also offer cast 316 stainless steel units at 2, 3, and 4 inch sizes rated at a full 275 psi at an operating temperature of 100 degrees Fahrenheit. We have larger cast strainers from 10 to 16 inches, which are rated at 150 psi at 150 degrees Fahrenheit. There are some circumstances where the customer has a pipeline with a pressure below 20 psi, which is the recommended minimum operating pressure for the 2596 strainer. We can still use the 2596 strainer by integrating a backwash assist pump, a pump connected to the backwash lines, and will remove the debris-laden backwash water. Another significant advantage of the 2596 strainer is that maintenance can be performed without removal from the pipeline. If service or maintenance is required, the cover of the unit can be lifted away, and inspection of the internals can be made without disturbing the connection on the pipeline. A good selling point is that the 2596 strainer is ideal for a remote installation. With a control panel and proper setup, these units will automatically backwash, so they can be left unattended for weeks or months without any intervention from an operator. Eaton produces the only convoluted element which provides the maximum screen area in the industry. This greater surface area produces better results, which gives Eaton a distinct advantage over the competition. We offer cast and fabricated materials, including a range of compatible construction materials and alloys to meet the needs of customers with specific requirements for wetted materials in the pipeline. If the customer has dimensional limitations, we can provide custom strainers. If the vessel must operate under unique design criteria, such as high temperatures, adjustments can be made for the corrosion allowance by thickening the shell of the vessel. If there are seismic requirements, we can design that into our fabricated units. We also offer a wide range of internal and external protective coatings and linings. Many are standard, but special coatings can be offered to meet the customer's requirements. Let's review how the Model 2596 strainer operates. We can see that a small portion of the element is cleaned by a reverse flow of the strained fluids. The majority of the process water continues through the strainer, and only a very small portion of that inlet flow is used to backwash the strainer. The remaining screen continues to strain, providing uninterrupted flow to the process. For example, if we have a 10-inch 2596 self-cleaning strainer, the backwash line would be 2 inches, and that backwash water would carry the debris away from the strainer to be disposed. The backwash time would be dependent on the amount of debris that is contained in the process water. Sometimes process water is very clean, and a backwash might only be required once every day. Sometimes the water is very dirty, and every 5 or 10 minutes a backwash cycle will be required. Therefore, our strainer controls include an adjustable cycle timer from 6 seconds to as long as the user needs. The 6-second timer is really too short to be usable. Those ranges are only for testing purposes. The end user could customize the program to whatever time cycle they require for the application. For example, it could be a 2-minute backwash cycle every 2 hours or a 4-minute backwash cycle every 6 hours. Here are some of the applications that use the 2596 strainer. The first application is seawater. We have strainers installed on platforms, including oil rigs, which would use seawater for cooling purposes. Facilities that use raw water from lakes as service fluid may also require a 2596. In spray nozzle applications, the 2596 is used to strain water so that debris won't clog the nozzles used for cooling purposes. Other applications are well water, irrigation, and membrane protection in drinking water applications where well and river water are used. The strainer would come before the membrane system in order to remove coarse solids such as sand and silt so that the membrane wouldn't be overloaded with large amounts of debris. The 2596 is extensively used in wastewater, not primary wastewater, which is also referred to as sludge. Instead, we would want to use the 2596 in the secondary effluent stage to remove any debris that might fall into the process water. Now we'll review the application sheet. It includes what you need to know as a technical sales or service rep to accurately quote the correct strainer. Please refer to the latest application data sheet. Confirm that the fluid being strained is water and not crude oil or liquid chemical because the strainer is not designed for those fluids. We have other Eaton products designed specifically for those processes. You must also confirm the flow rate to make sure that the 2596 is installed and sized correctly, so it yields a line velocity flow of 6 to 10 feet per second. Once you've determined the flow rate, size the strainer accordingly to make sure it's not starved for flow or overburdened with excess flow and debris. For solids loading, the standard recommendation is 200 parts per million max. Consider the flow in gallons per minute. For example, if you had 1,000 gallons per minute of flow, that would amount to 2 pounds of dry solid waste on average. Be sure the applications you're quoting have 200 parts per million or less of debris. If the amount exceeds 200 parts per million, you should consult with the engineers in the U.S. to ensure that the application is compatible and an accurate quote can be developed. You must also evaluate which solids are found in the water, as well as the volume of debris in the water. Some examples of this debris are grass, sand, shells, or algae. An important consideration is that the 2596 is not designed for the removal of algae, as it is sticky and stringy with a tendency to adhere to the screen and becomes difficult to remove. There are 3 different types of straining elements: a mesh, which has a convoluted shape, a perforation that is also convoluted, and a slotted element, Eaton's Dura Wedge, which is also known in the industry as wedge wire. The filter media should be sized to at least 1/2 the size of what you're trying to protect. For example, spray nozzles are 1/4 inch, so you want to use 1/8 inch or smaller slot or a perforation in order to protect that nozzle. You want to use that size or smaller in order to protect the equipment downstream. Perhaps it could be a heat exchanger with tubes, and you need to know what the tube diameter is in order to protect them from being clogged. We offer a wide range of construction materials such as ductile iron, carbon steel, and 316 stainless steel, but the standard is cast iron. We also offer special materials such as bronze alloys like cast aluminum bronze, special stainless steels like 2205 stainless, and fabricated Monel strainers. Let's review the different types of alloys available. 2205 is a stainless steel alloy that is more corrosion resistant than 316 stainless steel. Many customers require a 2205 duplex for added corrosion resistance. Monel is an entirely different copper and nickel-based alloy with high strength over a wide temperature range with excellent resistance to many corrosive environments like seawater, while a 316 or a 2205 duplex might be susceptible to pitting and corrosion. If the customer wants superior corrosion resistance, better materials are required. Though this will cost more initially, it will significantly extend the life of the strainer. For example, a seawater strainer made of Monel might last a duration of the plant, possibly 40 years or longer. However, a 316 strainer that's in saltwater might only last 10 to 15 years. If someone requests a special alloy, you want to contact the factory to see if we can fabricate that unit in the specific material requested. Another option in seawater applications would be to fabricate the strainer in carbon steel and internally line the strainer shell with a neoprene rubber. In order to design the strainer, we need to understand the parameters to determine whether it will be custom or standard. It is important to identify what power supply the customer has, and then we can design the control systems to match their needs. We have input starting at 115 single volt phase going up to 230, 280, and 575 volts. We also have international voltages ranging from 380, 400, and 415 volts with 50 and 60 hertz. This information can be located on the application datasheet. Let's consider sizing. We need to discuss this with the customer to give them an idea of what to do with the backwash flow. Our strainers have an average backwash flow, regardless of size, of about 3 to 5% of the inlet flow. We need to help the customer plan ahead as to where the backwash flow will go. There must be a dedicated line for the backwash. It cannot be run into a floor grate or floor drain due to the risk of flooding. This dedicated line is especially important for larger units because there's a significant amount of backwash flow, sometimes hundreds of gallons per minute. Ideally, we would want the strainer or backwash line to come out of the side or the bottom and go straight down to the plant's backwash pipe, so there's no back pressure on that line. In most cases, that's not feasible, and the backwash line may be 20 to 30 feet away. Find out how long the backwash line is going to be, if there are any elbows, or if there's any elevation. Any back pressure or friction losses that are incurred by that backwash line are going to reduce the efficiency of the strainer operation. We can compensate for all of that, but obviously we need the information first in order to develop an appropriate design. Will the strainer satisfy the customer's needs? We want to ensure that it provides adequate protection for the downstream equipment. Let's review sizing. First, provide the application worksheet, which can be found on the website, and help the customer complete it, including any additional specifications, such as mechanical or electrical. A large project may have dozens of specifications that you will need to obtain from the customer. Be sure to ask for all the documentation. Are there any criteria that have to be met, such as corrosion allowances? Does the strainer need a non-standard design pressure rating instead of 150 psi? Find out if any non-destructive examination is required, such as radiography. We also need to know how much radiography. Is it 5 or 10% spot weld? Is it 100%? That information is necessary because it impacts the price of the strainer. We also offer liquid penetrant tests, magnetic particle tests, positive material identification, or can run test for any special certifications needed. Now, let's review our straightening elements. First, we'll go over the convoluted element mentioned earlier in this presentation. Typically, the largest size is about 1/4 inch. The smallest size possible for a convoluted element is 1/32 inch, or 1 millimeter. If the customer needs a finer strainer to capture fine sand or silt, then a convoluted sinter bonded mesh should be used. Our sinter bond element is made up of 3 layers. There's a perforated layer for strength, a coarse mesh spacer that provides a gap between the rated mesh and the perforated backing, and finally the rated mesh in the back. This manner of bonding is called a sinter bond effect. We use pressure, then heat those 3 layers together to make one sheet for a very strong bond. We typically provide that in 316L or 316 stainless steel. Next, we have the Dura Wedge or wedge wire element, and it's available in 100 micron through 1/4 inch slot openings. It is available for 316 stainless steel, which is standard, but we also can provide special materials including Monel 400 and 2205 stainless steel. Pictured here is a Model 2596 strainer. Here's an image of the 2596 strainer that shows the interior parts. You'll notice that there are no screws, washers, or other components to hold the internal pieces together. A common problem in many automatic self-cleaning strainers is inefficient backwashing due to debris lodged in the strainer element. The Model 2596 2 through 8 inch strainer features a unique vane plate positioned at the inlet of the strainer element, where it contacts the process media before it enters the element. The vane causes the incoming liquid to move in a circular motion, forcing the debris to lay up against the surface of the strainer element rather than lodging in the element's openings. Lodged debris can negatively impact the differential pressure across the strainer, resulting in a shutdown of the strainer and manual cleaning of the element. Sand Peller technology helps prevent this situation and delivers easier and more efficient backwashing. Something that we commonly see is an application with a flow rate of 500 gallons per minute, and we have 3 strainers that are appropriate for this flow range. Sometimes the 4-inch strainer might be a little too small, but the 6-inch might be a little too big, so the 4L strainer was developed. The 4L strainer is a combination of the 2 and features the 4-inch nozzles and flanges, but the body size of the 6-inch, so more flow can be accommodated. Pictured on the right side of the slide is a 10-inch 2596 strainer. On the left is an application located in the western United States that includes 5 30-inch strainers. What are the advantages of the 10 through 30-inch strainer? They include higher flow rates and a wide range of materials. An expanded range of design criteria means we have no dimensional limitations, and internal linings and coatings are available. One example is in an application requiring a neoprene rubber internal lining, which would be excellent for seawater applications. As you can see from the slide, Eaton has many options to meet customers' unique requirements. Eaton automatic control systems are designed to monitor and operate backwash cleaning systems. The design allows field adjustments to suit the demands of the service conditions, ensuring effective cleaning with a minimum use of backwash fluid. The ACS-1 features a NEMA 4-rated panel box with an adjustable timer, differential pressure override, and 10-amp control relay for backwash valve activation. The ACS-2 has all the features of the ACS-1 plus a motor starter. The ACS-3 has all the features of the ACS-2 system and includes a 460-volt, 120-volt step-down transformer. ACS-4s are meant for international applications. We can put in a specific transformer to step down the input voltage as required. Therefore, we can provide controls for any country in the world, optional designs to meet specific requirements with special wiring arrangements, and panel boxes can be furnished. Moving on to control accessories. Our standard control includes a fabricated control panel and a motor-operated automatic backwash valve. The motor-operated control panel would provide power to the valve actuator. Eaton also provides a differential pressure switch with a preset setting which can be installed across the inlet and outlet nozzles of the strainer. The DP switch operates by sensing high differential pressure across the element due to debris as the element becomes clogged. So, for example, if the DP switch were set to 3 psi, it would activate the backwash cycle when the differential pressure is reached. This is in lieu of a timer. An upset condition might occur between the scheduled backwash times, and this is where the differential pressure switch protects the strainer from high solid loads. We can provide flow and differential pressure monitors for both the line pressure and the differential pressure. There are many options we can offer customers when providing custom control panels. Perhaps a customer wants to know if there's a problem with the strainer motor, such as motor overload, and the strainer shuts off. Eaton can supply output that alerts the status of the strainer, or if the strainer shuts off. Another option, Eaton can provide one control panel for many different strainers. For example, you can have up to 10 strainers per application with a single control panel that will integrate those units and provide interlocking to backwash one strainer at a time, sequentially, from strainer 1 through 10. Strainer pump interlocks can also be provided, so strainers only function when you have water flowing through the system. Eaton can provide different system faults. As a standard, we provide a DP switch contact output, and that's just to signal a high differential pressure across the strainer. We make use of PLCs, programmable logic controllers, or DCSs, digital control systems. Many times a customer may have a DCS, and then we could then apply an Eaton-supplied PLC to communicate with a customer's computer control. The 2596 strainers are typically installed in pipelines with a minimum pressure of 20 psi, but there are many instances when the strainer is installed in pipelines that have less than 20 psi. For example, on the suction side of a pump or the gravity-fed intake line of a plant with only 5 to 10 psi. A 2596 strainer can still be used as long as proper modifications are in place. In those instances, we would take our standard strainer and implement a backwash assist pump, pictured on the right side of this slide. It is a close-coupled small pump that is placed in line with a backwash line. So the backwash pipe would come out of the strainer, then run through the automated backwash valve, and then into the suction side of the pump. When a backwash occurs, the backwash valve opens. When the backwash valve reaches its full open limit, it energizes the backwash assist pump and creates a suction or a pull on the backwash line to aid in pulling out debris from the strainer. The backwash assist pump works well because the backwash water can be pumped away. Not only does it aid in cases of low system pressure, but also when a customer has a long backwash pipeline or elevation on another floor or level of a plant. So why do you need a pump? If a line pressure is less than 20 psi, or if there is a significant pressure loss or excessive head in the waste line or backwash line, a pump will prevent loss of efficiency in the strainer. Eaton's main competitors in automatic strainers depend on what part of the world you're selling. Here in the Americas, we see a lot of competition from Fluid Engineering, SP Kinney, and RP Adams. Outside the U.S., we might see more competition from Hydac or Oraval. We must know who the competition is and how to adjust our pricing appropriately so that we can provide the customer with a superior product at a competitive price. Here's some information you'll want to review with your customers during the quotation process. This slide shows an application worksheet that we referred to earlier in this presentation. This sheet must be filled out with the information you will gather from your customer and will review with the engineering team. This form can be found on Eaton.com. Thank you for attending this presentation.